Black holes have gravity so extreme, even light cannot escape from it. Their gravity is so powerful that it can literally bend space and time. You may have heard that the gravity of black holes is intense, but you have no idea just how mind-bogglingly powerful it really is. In fact, inside the invisible sphere around the black hole called the event horizon, the gravity is so strong that not even light can break free from its grasp once it crosses. The pull of gravity accelerates anything that gets near it to an unbelievable speed. It's almost unimaginable to think about. Even the supermassive black holes have density beyond comprehension. The gravity of black holes is so intense that it actually warps space and time around them. It's almost like a deep hole in space-time itself. As objects fall towards the event horizon, they start moving faster and faster, almost approaching the speed of light. Time slows down significantly from the perspective of someone outside the black hole. This gravitational time dilation happens because the space-time curvature accelerates time for objects close to the black hole. It's one of the strangest precise predictions of Einstein's theory of relativity, and black holes confirm its reality. The edge of the black hole's grasp is called the event horizon, which marks the point of no return. Once anything crosses this sphere around the black hole, it can never come back. The event horizon is the ultimate boundary between the black hole and the rest of the universe. But the event horizon is not a physical surface. You couldn't stand on it because you would instantly get stretched and crushed by the black hole's gravity. In fact, from your perspective, nothing special happens upon crossing the event horizon. But anyone on the outside will never see or hear from you again after you cross. You'd simply disappear without a trace. It's the point where even light loses its ability to escape. Imagine throwing your smartphone into a black hole. As it accelerates faster and faster toward the event horizon, a distant observer would see the phone slow down, even while its image gets dimmer and more redshifted. Just before it hits the horizon, its image would fade completely and suddenly vanish from sight. From the phone's perspective, though, it would pass right through like nothing happened. However, now there is no going back. Its fate is sealed to move inescapably closer to the black hole's singularity at the center, where the same phone would be violently stretched out by gravity tidal forces and crushed into the central point of infinite density. Talk about one missed call you could never get back. A black hole is named because it traps light and does not let anything escape after the event horizon, even photons. The gravitational pull becomes so overwhelming close to the singularity that the escape velocity exceeds even the speed of light. Since the most powerful telescopes detect heavenly bodies by capturing the light they emit, black holes themselves emit no light. The only giveaway to detecting them is from the effects their gravity has on stars and gases swirling around them at incredible speeds. Their darkness also enables them to literally swallow stars that come too close without anyone seeing it. Happen as they disappear without a trace behind the event horizon. No form of light penetrates through to enlighten the secrets inside, which is why the insides of black holes remains one of science's greatest enduring mysteries, their contents hidden in the shadows of the blackest void in the cosmos. Astronomers have discovered supermassive black holes many millions or even billions of times the Sun's mass at the center of virtually every large galaxy surveyed, including our own Milky Way. They form an anchors at the very core with their phenomenal gravity, around which entire galaxies rotate like water swirling towards a drain. But do not worry, the monster black hole at the heart of the Milky Way called Sagittarius A is over 25,000 light-years away. We are far enough to not get pulled in, but its staggering size filling the central region still boggles the mind. Now consider that some quasars host black holes billions of times the size of Sagittarius A, with event horizons wide enough to swallow entire solar systems. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius AA, which seems quite small at just over 4 million times the Sun's mass. But packed tightly inside its event horizon, this is still an unfathomable density, jamming the mass of 4 million suns into a tiny region, surely making Sagittarius A one of highest densities for that neighborhood. Now try to visualize how much invisible extreme curvature our galaxy's core is causing that is still affecting stars many light years distant. The faster stars and radiation orbit around Sagittarius A. The more this shows the colossal concentration of mass-warping space-time into intensifying twists, sending surrounding gases swirling towards doom at nearly 3/4 light speed before they ultimately get swallowed through the galaxy's drain. The crushing gravity and extreme space-time curvature at the core means we will likely never know what happens inside the bottomless pit within a black hole's event horizon. But physicists and mathematicians have described mind-bending theories about the craziness at play. General relativity mathematics shows the internal gravitational pull could become infinite at a central point deep inside called the singularity. This means the laws of physics completely break down beyond our understanding. Perhaps even stranger ideas like hidden passages connecting to parallel universes await, or the chance to time travel backwards. But nobody knows if utterly crazy concepts like these any real chance have of being possible within the mysterious interiors. One thing's for sure, black holes will likely continue concealing their perplexing secrets, untold mysteries of space-time cloaked behind the veil of their dark event horizon, leaving their true interior nature forever shielded from our sight. Now here is the surprise twist after building up all this mystery. The monstrous gravity that makes black holes so notorious for destruction is also the reason new stars can form within galaxies. Shocking but true, the jets and winds from black holes that intensely stir surrounding gases also compress clouds of hydrogen, which then ignite into brilliant new stars. Who would have guessed that these gravitational beasts voraciously feeding on matter also provide the vital astrophysical mechanisms needed to spark glittering new stellar birth? Truly a strange dichotomy of notorious destruction yet essential creation, fluidly balanced within the depths of galaxies. So black holes have a Dr. Jekyll and Mr. Hyde duality about them. Their tremendous gravity tears stuff apart while simultaneously spurring new structures. Nothing exposes this central role in cosmic ecosystems more than the great irony that these obscure destroyers also catalyze the dazzling formations of new stars.